All right, so welcome to part 3 of finding domain of function. So if you have not gone through the other 2 videos, okay, you can actually check around and see the part 1 and the part 2, meaning we have solved question 1 and we've also solved question 2. All right, so we are going to question 3. Okay, now here we have logarithm of natural number. Okay, ln, most of them call it ln. Okay, ln. Now this can also be written as log x minus 1 base e. All right, it's same thing with it. Logarithm to base e is called logarithm of natural number. If you check your calculator towards the right hand side, the right hand side of the button, you will see this very equation there. So this very statement there. All right, so how do we solve questions like this? How do we know this? So what you do is that you are going to do test, try and error. Pick your calculator, okay, check out. Now let's assume that I'm coming from this direction. Let's assume that this is actually ln x. Let's assume that it's actually ln x. And we're looking for the domain. Domain are set of values of x such that if I put it inside this very problem or this very function, I'm going to get a function that actually exists. Don't forget that definition. Or a function that is actually continuous. So like I do say, looking for domain also means looking for a point of continuity. If I say find a domain, it actually means find a point of continuity. That's just that, right? So now I will check my calculator. I will find out. I said from -1, 0 and 1. That means negative number, 0 and positive number. If you put -1, you notice that in the calculator you are going to get math error. You can try that, pick a calculator and press ln -1, you are going to get 0, math error. If you press ln 0, you're also going to get math error. Can you see that? Then if you now put 1, 2, 3, that is when you now see this thing. You now see a number given to you, real numbers. So what does that mean? It means that number that should come in here, or the values of x, are number that were greater than what? 0. That's what it means. So anything that is less than 0 cannot come in here. So if you are having -1 and 0, -2, -3, -5 down, from you are looking at your number line, anything down towards the left, then such number cannot come in here, right? So with that, we can now say that for us to solve this problem, then we must set this one to be -1 greater than what? 0. So the constraint is almost like that of inequality. Sorry, that of this one, fraction, when we had fraction. So if you have followed our series 2 or part 2 of this video, you'll be able to check that. So go through our part 2 and be able to see exactly what I've just explained here. But the difference is that here we have greater than 0, but in this case here we have greater than or equal to 0. So here we included equal to 0, here we excluded 0. All right. So with this now, our answer becomes x greater than 1. So that means that every number that is any number that is greater than 1, okay, it is number that we are going to put in here. Now try it now. If you try 1 here, you get 1 minus 1, and that is 0, and that doesn't exist. So the number from 2, 3, 4 to infinity are the numbers that we should expect in this particular function. All right. So this is how to solve domain for logarithm functions like this. Okay. So see you in my next video. Ensure that you check part 1 and 2 so that I can flow with all these very problem. All right, see you in my next video. This is the Young Modular Solution.